great, everyone. So let's do a very quick demo of the global error response policy for Flex Gateway works. And we'll start with a small demo and then walk over the code a little bit. So, right, let's see how it works. I do have an API instance already deployed in API Manager. Yeah, it's called Echo API. It's just forwarding the requests to Postman Echo. It is deployed on my local Flex Gateway. Right, so I have a Flex Gateway running locally and locally, so localhost. It looks like this has been forwarded to Postman, so it looks like this, right? It just echoes my requests back. In this case, we wanted to try error handler, so we will simulate error responses, right? I can do it with 400, 500, and these are the standard responses from Postman. It just echoes you, like sends you the body status. So our goal is to configure a policy in the API manager, right, which will make it look like it's been handled globally and having a similar format for all the error responses. Let's see how it could be done, right? So if we go into policies, we will add an inbound policy. Here is our custom policy, which we published onto Anypoint Exchange, right? So this policy is now being part of our API catalog and could be used by any of the API catalog APIs and instances, right? So if we go here, the configuration is being done in the error mapping. You just add one, you specify the code you would like to intercept in response, let's say 400. And then here, there is a list of key value pairs, which will form the fields of your error response, right? So currently, I just decided to use DataWeave here at every field because it's simpler. It's maybe not the most performant way, but it's like a very flexible way to start off and test the policy. So we will have a field name type with this value, right? The good thing is, since this is DataWeave, right, the values you can use in the fields either in the key or in the value. You could use the values of the payloads of either your request or your response, so the headers or the body, and you will see this is exactly what we are doing here in the fourth one. So in the detail field, we will either use the payload, so the whole body of the response, or there is a default value. Right, and let's just say we can reuse here an attribute of the incoming status code, or just like hard code 400, since we know we are intercepting 400. Okay, so let's apply this. You will see that policy is directly applied on my local Flex Gateway. Just give it a sec, right? So here it's been applied, and then basically it's done. So these are the logs from the policy itself. And once we are doing this, right, if we are sending a 400 request again locally, you will see that this is now, so the original response was like this, it was intercepted, right? So it was put into detailed. This is the payload, which we saw. Then these are the new fields added by the policy itself, right? If I go to 500, it's not intercepted at the moment. So it's a standard response. I can go and add another mapping to the policy, right? So this is my first one. I can add another mapping. Let's say now I want to intercept 500. Let's leave all the fields here, even the 500, or maybe let's add a new field. Let's say type is, oh, this is this, you could also specify the response format here. It could either be a problem JSON, right? This is basically MIME type of your response, right? So 500 is not yet intercepted, hence this is a JSON, right? The standard Postman response. And we will see now this MIME type being used once we intercept 500. Let's just see that we can do changes here. Just for fun, save this. Right, policy is again being applied. Yeah, and once it's applied, we can also intercept the 500 response. right? So this is what we added, and this is the original response. And as you could see, the MIME type of the response is the problem JSON, right? So this is the common standard you could use for specifying your like global error handler MIME type codes as part of the RFC specification. And right, so the cool thing here is, let's say we go back to the response, right? If I configure the policy, it doesn't, so it supports multiple MIME types, right? So we have our 400, 500, and for the 500, let's say I decide to return an XML instead of the problem JSON, right? Let me just update the policy. And once it's deployed, and let's see, so I guess it's done. So now instead of the problem JSON here, I expect an XML also in the body. So the response will be formatted as XML, right? And you can see this. So basically right, so the error, this is predefined, but then these are the fields configured. So the details, status, title, and type, right? So same as JSON, just converted as XML. And right, so you could do multiple types here for each intercepted error code. Could be either JSON or XML or problem JSON. And that's the core functionality of the policy, right? So that's for the demo. Now, how it was developed, basically using the Flex Gateway PDK, so policy development kit, right? If you want to do one by yourself, you just come here, and the documentation is very detailed, right? You have all the prerequisites which you need in order to start. You have so PDK is actually like, right, an SDK which you use to develop your policy. You just install all the dependencies, and then using the CLIs, you bootstrap your project. And once the project is bootstrapped, you get this kind of structure. Well, apart from all the code and examples which I added myself. And then, right, so Makefile is like your entry point into executing actions of your project, right? For example, right, yeah, you can do make build, make test, or once you're finished with and tested your policy, you can do make publish, and this will publish it to the Anypoint Exchange. So all the make commands are described here in this file. And then basically the PDK is using Rust and Cargo. So Cargo to specify your developments and tests. So it's like an NPM in the Node.js world, and then Rust to implement the actual logic of the policy. Right, in this GCL file, you specify um, how the interface of your policy looks like. So this part, where's the policy? Yeah, so if we go again to the policies, here. So this interface, um, how, how the policy configuration, which fields it needs look like, is being specified here in this GCL file. And then it's been compiled into Rust code, and then this librs file is using that compiled configuration for its internal business logic. So the fields you specify here are available to the logic. And right, so this is the code. As mentioned, it was written mainly using kind of context engineering. So, so the context engineering approach is, I honestly, I didn't write this code. Well, of course, I reviewed it and put some commas here and there, but basically the whole complete working code was developed by Claude. And how does it work with context engineering and Claude? So the approach I used here, so-called product prompt engineering, so to say. So product request prompts, right? And to use this, you basically, let's say you just bootstrapped your project, you describe your feature initially. So this is a lot of, this doesn't have to be a lot of text, but in my case, I was very detailed. So the more detailed you are, the better. So, right, I just describe kind of owner, or like I would like to have a like highly configurable and performant error response handler policy with these and these functionalities, and this is what it will do. So this file is, yeah, this is where my work was focused on initially. And then you have some predefined Claude Code scripts. So how does it work? If you start Cloud CLI, here in the Claude folder, you have some commands like generate product request prompt, for example. You can read it all. It's just a prompt, more or less, but wrapped into a Claude command, right? And then you do generate PRP and then your file, right? Initial MD, for example, this one. And so the Claude code will execute that prompt over that feature you described, and it will generate the first PRP for you. The PRPs are being put here under this folder. And once I did this with my initial feature request, this specification was produced, right? And so it's twofold. You describe your feature, and then it's kind of the specification is being generated, and it's used also as the description of your project and as a like an more or less documentation and architecture of what this project, in this case policy, is about. So I find it really, it's really cool, basically. So you like your work is being auto documented too, right? So you can always read these PRPs and then you see so what was being done and why, right? And then once you're ready with your PRPs, you review it, of course, and when it all looks valid. And maybe one more note. So in order to generate a perfect PRP, well, perfect never exists, but a very good PRP, you would like to give Claude Code as much information as possible. So in my case, in order to make it look good, right, and in order to make the configurations and code being generated properly, I added the documentation of the PDK into my project, right? It's under here. I specified in my initial feature request and actually in my overall Claude. So this Claude file is like the overall context for the whole project, like from the technical point of view. So this one here says that you will find PDK documentation under docs gateway file, right? So it's not committed into repository, of course, but it's present locally. Then I also downloaded some examples of existing policies, right? Like DataWeave, data caching policies. So these are examples from the Flex Gateway PDK repository, which I like downloaded locally so that my Claude Code agent can use these examples and documentations to produce its own code. And this is like maybe the biggest hint here with all this, right? The more examples, the more description you give. So this is your context engineering in the end, the better the result is. So in my case, since I really gathered all the working examples and working documentation, which exists at MuleSoft, which is a good thing, the Claude agent could just produce a working policy. So I really, all my focus was on describing the features, right? So when Claude is ready, you just publish your policy, or you can even ask it to publish itself, and then it's done. One really, really critical hint in all this context engineering process is yes, you must have a working local testing setup, right? So in my case, it's so with PDK, you test locally with the Docker Compose. And one thing, kind of useful thing I added here is a script which allows Claude Code to run tests, right? Which you specify here under test requests. You have kind of integration tests, which really spin a local Flex Gateway for each test with some mocked APIs and context, right? So in this case, I'm testing a 500 response, just for example. So for each of these tests, like a local Flex Gateway instance will be spun in the Docker container. And a really good exercise here was to allow Claude, when it's running the tests, to see the logs of the Docker container, which wasn't there by default, right? So then so it wrote itself this bash script to see the logs. I didn't write this. And once this was done, then, developing and testing the policies was just a matter of time because it could write code, so write tests, then, write the code, see why it's not working and it's not matching. And while I was drinking coffee, it was actually doing this. Right. So the whole code, including all the scripts and tests, is published onto GitHub. Feel free to fork, use, command, or extend. Any contribution is welcome. I hope you like it, and thank you for your attention. Enjoy your day.